Sketch a possible graph of f with the following conditions. F prime is greater than 0. Since the first derivative is positive, that tells us that f has to be increasing on that interval. Up next, f prime is less than 0. Again, the first derivative tells us whether the function is increasing or decreasing. Here, it's decreasing because the derivative is negative. Then we have the second derivative is greater than 0. The second derivative tells us about concavity. So we know that f is concave up on that given interval. And then the second derivative is negative on -2 to 2. That tells us f is concave down. Then we have the limit as x approaches -infinity of f equals -2. That is a horizontal asymptote on f. And the next limit as x approaches infinity, again, another horizontal asymptote. So let's sketch what we have. I'm going to start with the asymptotes. We know we have an asymptote at 0, and we have another one at -2. F prime is increasing from -infinity to 1, and then it starts decreasing. So something's happening at 1. We know that there is a maximum because f prime is increasing and then it starts decreasing. So we know there's a max at x equals 1. The next thing we know is the graph is concave up. The graph is concave up from -infinity to -2. And then it starts turning to concave down from -2 to 2. So that's telling us that there's an inflection point at -2 where it changes concavity. So let's say that is somewhere down here. It could be above. We don't really know exactly. We also know there's an asymptote. So we're increasing, changing concavity, and then it starts eventually turning down at that max. We know it's eventually going to approach 0. So it looks like there's another inflection point and it changes concavity. That's not in the given conditions, but according to the sketch that I've got here, there must be an inflection point somewhere in here. So this is just one possible sketch of f given the following conditions.